I'm Kelly, and I'm a software engineer at Twitter. If you saw Lisa's talk, that was the architecture talk. This is the Twitter ops talk, I guess. Today, I'll be talking about what I've learned about debugging distributed systems end-to-end with the quality engineering team in data products, formerly GNIP, at Twitter. When I first came to Twitter, my manager was one of the OG GNIP engineers who later transitioned to the management side. And from him, I learned about where we are now as the data access pipeline part of Twitter, but also where we came from as GNIP. So as GNIP, we wanted to be Grand Central Station for social data. Automatic, WordPress, Discuss, Twitter, you name it, we ingested events from it, converted them into a common, easy-to-parse JSON format, and streamed them out again to our customers. GNIP was known for the quality of our data. We do our best to carry that quality and attention to detail forward. Eventually, Twitter saw our value as a source and bought us, but some of the things unique to the GNIP culture and operational mindset lived on, especially in how we think about and test our systems. We don't just rely on engineers writing feature and unit tests and SREs keeping our infrastructure going, but we also have a team of testing and ops folks that we call quality engineering. QE exists in its current form today because we're one giant distributed system bridging Twitter and our data customers. I like knowing how things work, but also how they came to be the way they are. No system or engineering culture is an island in time. Testing our system end-to-end started when GNIP had just a few engineers, and it was just engineers writing tests along with their code and doing QA, and it was pretty bog standard, but we just had a couple of apps then. As we grew from GNIP into offering a wider variety of products, we added microservices when we needed them, and soon no one person or team in the organization had the whole picture of everything at a detailed level in their head. Like, we're not Netflix, but it still happens. So feature teams could write plenty of tests for their own services and interactions with their immediate dependencies, but we didn't have the consistency between products that we wanted, and in some cases, we couldn't figure out why our system produced certain outputs. Our quality bar just wasn't where we wanted it to be. So the quality engineering team, if data products is Grand Central for Twitter data, makes the trains run on time. Today, I'm going to give you a motivating example of one of our products that QE tests, talk about our approach to testing the whole system holistically, cover some of the challenges we faced in trying to come up with testing strategies that are tailored appropriately for the work that data products does and the systems we have, and I'll cover some of the tools we've developed in the process of trying to write and enable feature teams to write the right tests despite these challenges. To start with, I'll define what QA actually does. So QE writes tests that behave adversarially to determine how our systems actually work end-to-end. Then we convert them into guardrails that confirm the system continues to keep working. In order to not disrupt the real streaming customer experience in production, we have our feature teams deploy everything to an environment with just fake clients that we control, and then we run a suite of stress and operational tests before code goes to production. And that's our staging environment. We also have a separate experimentation environment, and that's not our staging environment. This is basically like a mirror of production. Anything deployed to staging is done so with the expectation that it will end up in prod unless there's something awful. We handle real Twitter data in real time in our staging environment, just like we do in prod. But because many of our products are streaming instead of request response and are not accessed through a browser, we have a set of operating constraints that are relatively unique for part of Twitter. Our clients just kind of sit there and consume data. They're fairly passive. They're people making financial decisions and writing academic papers. So we just want to make sure they get all the tweets and all the tweets have the right parts. We also run some of our fake clients against production data products, so we can compare what we're seeing in those fake clients in staging and production during the soak period before deploys. But we have the staging environment in particular just for rattling our system end-to-end as it would be in prod after the deploy and seeing what falls out. The quality engineering team handles the deploy and also live interaction testing for the whole system of multiple data products. Because of the soak period and the comparisons we do, rattling the system end-to-end and putting new things in production are pretty tightly coupled for us. We use the data from our fake clients to determine the steady state of the system. So, does anybody remember the DDI DNS adage from November of last year? Okay. Yeah, well, it was fairly big for us, and it took a pretty big chunk out of our expected downtime for the whole year. We operate in a mainly streaming microservice-based environment. The QE team is in general most interested in trying to find causes for your classic distributed systems problems like lag or consistency of output of the whole system, and looking for unforeseen results from interactions between parts of the system that are supposed to be cooperating. So the dyne outage we definitely couldn't predict, but if you're just shipping a new feature to production, there's potentially going to be something wrong. So we have this staging mirroring prod setup with a soak period, because it allows us to see what will happen in prod before small interaction bugs in particular get there. So tiny cuts, if you have enough of them, still kind of compound as a pretty big injury. Our customers are making decisions that impact the way they do business and writing academic papers and all sorts of stuff with our data. So the kind of testing we do for data products is at the application layer and primarily from a customer's point of view. End-to-end testing takes place in both a gray area between services and outside the system boundary in our fake clients. So it makes sense it isn't usually the first thing in a lot of people's minds. Feature teams kind of tend to rely on it just working in the background unless we find an issue. But the number of bugs that we've found through this level of attention to detail have made it worthwhile. End-to-end testing is not a replacement for your garden variety feature unit testing. In feature testing, your engineer will muck out their edge upstream and downstream dependencies in order to just exercise the code they've written. The rule for us is a feature test doesn't go off one box, but this is live. In end-to-end system testing, on the other hand, nothing is mocked. All dependencies are up and at 'em, databases, networks, streaming connections, the works, because we're testing for live interaction issues in the whole architecture as a single entity. Well, bugs caught by other forms of testing could definitely have customer impact also. Our specific target with this kind of testing is faults and interactions between disparate parts of the system and fidelity between different sources of the same data. Finally, Twitter does have a whole organization devoted to making sure developers have solid tooling. Like, we have somewhere between 1,500 and 2,000 engineers. I've really lost count, so 20 or so of them can just work on CI and work on our build tool pants. But QE's not that. What QE is different. Our work is tailored just for data products. The Twitter observability team gives us tools to explore the state of the system once we do have data, but a lot of that data, in terms of the services owned by data products, is produced through the efforts of the QE team. An example of a product we validate on a continuous basis is PowerTrack. I'd like to briefly describe PowerTrack so that you can more easily visualize what I'm talking about when I say that QE is looking for interactions between systems in the case of this particular product. The fire hose is what we call the stream of all real-time Twitter data. There's so much of it per second that to consume the whole thing as a customer, you have to make 20 non-redundant connections to us to get all the tweets. PowerTrack ingests that fire hose, applies your custom rule set to it to filter out just the tweets you might not be as interested in, and serves you just the good stuff, all in real time with as little delay as we can manage. When we were getting ready to launch our most recent version of PowerTrack, we had two problems to solve. First, we needed to be faithful to our other sources of Twitter data, especially the old version of PowerTrack and the fire hose. We needed to make sure the new version wasn't lagging compared to the old version, especially if we were going to ask customers to switch soon, and that if we saw a tweet in the old version, we also saw it in the new version with all the same components. With this update to PowerTrack, we wanted to allow our customers to filter with more finely grained rules, additional operators, and maybe even more reliability. So this isn't like, your everyday push to production. This was kind of a big change for us. Now, planning for an average level of tweets per second isn't that hard, especially when we have decent steady state metrics, but planning for meeting our high water mark, on the other hand, can be a little bit more difficult. So that's our second problem. Most systems, a PowerTrack stream or a single fire hose partition is a pretty good example, should be able to handle a certain number of tweets per second comfortably as input without any human intervention, and about double that number should be handled without paging on callers, even if our observability setup starts emailing us and saying something is ugly. We'd rather be proactive than reactive, especially when it comes to making our customers happy. So what could we do to meet those needs and certify PowerTrack for release? So a book that's been sitting on my shelf for a while and kind of getting dusty, but I picked up again recently, is Puli is How to Solve It. It was written for kids in math classes, I'm going to be honest, but taking the time to think critically and analytically about your problems is pretty generally applicable. Puli has a lot of good analytical tools for problem solving, but his main idea is just easier to not try to tackle the whole problem head on. There are 4 steps to this approach, and I find sometimes the best thing to do is just to go back to first principles. I find it helpful to structure my thinking about how to go about finding solutions in this way. The first step is understanding. If an engineering manager comes to us and says, hey, I'd love to have a test for this and for this and for this, we need to ask some clarifying questions. We need to look at our existing metrics about the state of the system. We need to go talk to people who are working on the product and figure out what they think. If we can't restate the problem in our own words, or we don't know what we're being asked to find or show, it's somewhat difficult, or really difficult actually, to write tests. So we've gathered some information, but regardless of how well we understand the problem, we should still check back with whoever gave it to us to make sure that what our expectations are aligned with theirs. The second step, once we've got a problem, is to figure out an approach once we know what we're looking for. We could start with a list of potential approaches and try the best one. We could reduce our problem to just the essentials, or maybe there's some small chunk that needs to be solved first before the rest can be solved. Like, if we're testing something, maybe we need to get access to a database. Maybe we, whatever, just something small that you can pull off first. Thirdly, we'll try that out, and then finally, we'll figure out if it worked to our satisfaction. For the new version of PowerTrack, making the new rules API, which allows folks to add custom rules to their PowerTrack streams, behave more consistently and be more reliable, was a sub-problem of making all of PowerTrack reliable enough to meet our SLAs. Making sure our new operators work correctly was a sub-problem of making the new rules API behave more consistently. So the rules API is pretty simple. It allows you to upload rules in JSON format up to a size limit. When you've successfully added a rule, it should give you back a 201 and tell you which rule was created. If a rule already is actively filtering the stream, you should get back a 200, a message telling you so. If the rule set you were trying to upload couldn't be added, maybe it was too long, we reject it and tell you why. The fourth step in Puli's approach is to reflect on what worked and what didn't and try and fill in any gaps or holes in our solution. If we didn't get the end result we wanted, maybe another one of our potential approaches could work. Maybe we need to take a step back and find another small piece of the problem to solve before we can get to what we originally thought would be the first thing, and this is when we decide that. So one of the things we were working on adding with this PowerTrack update was the ability to filter on more of Unicode instead of just words and phrases in the various languages that Twitter supports plus hashtags. We wanted customers to also be able to filter with emoji code points in particular. One of these new operators, the soccer ball emoji, was not behaving as expected, which is, I guess, just what you get with a distributed system. Sometimes they do things and you can't explain it. We had system tests that added a couple simple rules and checked to see that what we got out of the system made sense, but we wanted everything to at least work for the day of release. Comparing data from PowerTrack streams with the same simple rules served from different Twitter data centers was a limited version of the problem of making any PowerTrack stream consistent with any other PowerTrack stream with the same filtering rules. We helped the teams working on PowerTrack write tests that compared soccer ball emoji tweets served by PowerTrack from our various data centers in our staging environment to make sure that we were seeing the right tweets when we expected them. Coming out of this deep dive into the PowerTrack product and the systems that make it up, I started thinking about the way I was approaching testing data products as a system and how it had been really helpful to just be able to concentrate on aspects of PowerTrack for a while. As at this point I was fairly new to Twitter and to the idea of system testing in general, I thought that the best thing I could try to do on my own, aside from whatever the day-to-day was to learn as much of our entire architecture in detail, which right now I think is maybe 60, 65 microservices as possible. So QE started experimenting with embedding with feature teams more often. We wanted to be visible every day and on people's minds so that we could get a better sense for what issues people had that we could take off their plates. Another benefit that we hoped for was the ability to pinpoint problems in that team's systems in areas that made more sense. So we weren't just beating on services that were already sturdy, that were kind of the obvious places to look, and ignoring things that might have been more weak. So these are all good things, but we didn't need to know absolutely everything about the system in order to just support it. Exploring and experimenting and gathering information are all important for building intuition about the system, both in terms of traditional QA and in terms of red teaming, but it was impossible for a handful of people, and especially not just one person, to have deep knowledge of our whole architecture at the same time. You lose context if you aren't in immediate contact with a service or a subsystem for a bit. The tests we were able to write at this point without enough context were often duplicating more localized tests that feature team engineers had already written. We were also leaving a piece of the system out of our model of data products, and that was the other engineers. So we had a pretty good set of experiments going, but trying to be end-to-end testing as a service was bottlenecking the other engineers at getting features into production. QE writing and maintaining all the system tests and system testing infrastructure controlled well for feature teams' possible blind spots with regard to their own code and things they might think were obvious, but needing to understand enough of our system in order to file tickets for our bug reports that would be accepted and acted upon was a drain on the amount of time we had available to write the right tests. Sometimes with our limited system knowledge, we would think we found a bug, but it was really expected behavior of the system that just wasn't documented, or that kind of customer input would never be presented to the API because there were 5 other systems between it and the edge. Sometimes we didn't have enough facts in our quiver about the expected behavior of the system and all its individual components to talk to the right person or team first. Our relationship with feature teams needed to be more collaborative. The way we were approaching system testing simply wasn't optimal for the organization itself. Now, Conway's law is that the systems that are created by any organization are reflective of how the people in that organization communicate with each other. A system has to be considered in the context of the people who work on it every day. And that's what this guy is saying too. It's really, if you're gonna think about testing something, you have to think about the people who wrote it as well. And if you haven't looked up this paper, totally do. It's all about like process and formal verification, and it's, some of his examples are like refrigerators, but it's really cool. So if you liked the talk before mine and you like this, you'll probably like that. So when another team made time for us, like with our work with PowerTrack before our latest big update to it was to be released, we had success in drilling down into that team's portion of the system and its dependencies and helping them with their interaction testing. But we were still having difficulty keeping up across the org, so it was time to reconsider again. So Sarah Mai is kind of the goddess of feature testing. Her blog post, 5-factor testing, is also something that I like to revisit from time to time when I'm not sure where to start with tests for a new feature or product. So I'm gonna paraphrase a bit. Good tests should tell other people how to use the system and what they can expect from it, even in faulty states. If we just reinvent tests that already exist, we aren't providing any new documentation on the system. And it's difficult to prevent future editions from moving away from the functionality that our customers are paying for without tests proving the entire system works and tests proving the boundaries of the specification. Good tests do not confirm information that we already know. Falling into the confirmation trap again doesn't help us challenge the beliefs of our organization if something's wrong with the system to motivate change. A good end-to-end test should do 2 things. Fail with the existing state of the system if it's behaving badly, and then once the system is fixed, continue to act as a should always pass guardrail until we reevaluate that test and decide if it's needed or not. Otherwise, we don't really need to add that test to our suite. So once a quarter, Twitter engineers get a week to write code to just scratch any itches they might have. Well, we were kind of in a holding pattern trying to keep up with everything everyone else was doing, writing all the system tests and doing manual testing. A hack week sort of snuck up on us. Part of our problem was our tools for the tests we were trying to write weren't the greatest. They weren't really written for anyone to use. So here was a nice sub-problem, really. Taking some of the load of end-to-end testing off of everybody, by iterating more complex tools into something simpler and easier to apply that other people might be able to use. A couple of my teammates worked on writing a new, cleaner version of some of our testing tools that hack week. So the idea was, with easier to use tools, we could get feedback on whether we were actually finding bugs sooner. And with enough reasonable tests as examples, we could even take the time to teach teams that already had domain expertise what to look for in test results when their systems weren't interacting correctly with one another. If we could teach feature teams what to look for, we could write some simple client code for our tools, then teach them to write system tests themselves, and then fit those tests together into an end-to-end suite. Then we'd really only need to step in ourselves to provide advice on how to use our client code, or to write and interpret tests in more complicated cross-team cases when we had time to dig in and explore. But we were running into another problem. Now our own expectations about the quality engineering team and where we fit as people in the org were different from those of everyone else. We eventually went over our managers, but now we had to harden and scale our new tools, gradually phase out the old tools, and get the rest of data products on board. We did a lot of pair programming, writing tests using our library, and explained why we thought it would be easier for everyone involved if we didn't try to duplicate the expertise and understanding of about 35 people with 4. So part of our initial problem was the overhead of our tools. With no product manager, it's easy to fall into a habit of building things just for our own team and automating things whenever we feel like it. But as a platform and tools team, that's not our job, and we're not our own customers. We needed to catch up with the amount of testing we should have been doing in order to best handle testing requests. And I, in particular, wanted to see if engineers following our process and waiting for us to catch up with our testing were happy, and they weren't. There were some grumbles. People were fairly patient with us because they knew we had a big job, but we needed to get smarter about our approach. When GNIP was much smaller and QE was just one person writing tests for a few other engineers at a startup, doing everything ourselves and building things with just our team in mind worked pretty well. But with 40-odd engineers adding new things every day, there's a lot more overhead. So when we deploy, what eventually goes to prod is what's running in our staging environment, which is a mirror of prod with fake clients controlled by QE instead of our real streaming customers. One direct benefit of feature teams writing their own system tests is that they're at least somewhat more likely to pay attention when those tests fail. So issues have started to get fixed faster. A team whose service causes a test failure was generally not able to get their code in production until they fix that code or fix the test that failed, since we treat system tests like a blocking deploy step for each service that Data Products owns. If folks want their new features in prod, fixing interaction and fidelity bugs has to happen first. So at least from the perspective of QE and me, this is a better method. However, this is still not a perfect system. So it's time to take a step back again and look for gaps in our coverage. Did we have the right tests? Were we too focused on a couple of products to the exclusion of others? What were we missing? Taking it back to the early days again, when we were GNIP, we had full control over our systems. It was easy to inject enough fake tweets at the top of our staging pipeline to hit our high water mark and measure the results both on the intermediate system and on our fake clients. As part of Twitter, though, our apps are connected with our in-house pub subsystem event bus, and we monitor our systems with tools maintained by the observability team. We don't control our entire environment anymore and had been missing a way to load up the whole system at the same time for a while, but we'd been hesitant to develop in this area since we'd also be stressing out the team that builds and maintains our pub sub infrastructure in particular. So up there on the left, I've got Ellen's tweet from the Oscars in 2014, and it was retweeted a bajillion times and favorited and whatever, but that event isn't really like the other two at all. So we had two things on our calendar: New Year's Eve and the migration of data products from the general all-Twitter messaging cluster to our own dedicated cluster. Data products engineers, especially the streaming team, wanted to know if we could help them plan capacity for high-load events like New Year's. And it was Hack Week again, so I paired up with somebody else to explore what tools we might already have for stress testing and capacity planning. So Twitter does have a backend tool called Iago for a form of stress testing, but it runs in prod, which would mean serving our people that are connected 24/7 as customers fake tweets. So that wouldn't really work for us. Fake tweets served by that tool are, of course, stopped before they get near the UI, but as data products, we have different priorities than some other teams in Twitter and people that don't do streaming. So data customers have somewhat different expectations of our API than people tweeting have from the Twitter UIs, for example. One pretty significant drawback of both our stress testing in the old GNIP environment and this other tool, Iago, is that they just replay recorded data. When testers use fake data for stress testing, they're unintentionally imposing further constraints on the system and are on their model of the actual system, and can then, based on the test results, reinforce part of the system that might not need to bear the same kind of load under either ordinary or above average traffic in production. So in the middle is a hurricane and on the right is a football game. Recording a known stressful event such as the Oscars, where Ellen took this picture, might be a good start for generating a fake data set, but the patterns that we're going to see in such a data set are not really applicable to people doing disaster recovery during Hurricane Maria, or to football games or whatever else goes on that causes load spikes for us. Requests per second load testing can definitely inform a picture of the client experience, but it's less of a primary concern since we're streaming. What we were interested in was more along the lines of loading ourselves up with input in terms of tweets per second, as we're a leaf node of Twitter, and our customers just hang out and consume data. So instead of taking the fake data approach, we decided to leverage what we already had, and in-progress migration to our very own pub subcluster, and the ability to subscribe to the stream of all tweets and tweet-related events as they're created in real time, just as if we were the initial ingest app at the top of data product streaming architecture. So we worked with the streaming team as well as the pub sub team to make sure that we could inject load into the topic the app at the top of our architecture reads from safely. We weren't using fake data, but we had direct access to all events occurring in real time. So we built a lightweight tool that allows anybody who wants to pick a topic to subscribe to, a topic to inject to, and a desired number of events per second to inject. We made two design decisions with our load tool. Like our original replayed load generation tool, the new tool has a number of workers that you can use based on how much you want your load to be multiplied. But two, unlike our old tool, each worker can be set to duplicate each event that's ingested from our pub sub architecture a set or random number of times. So in this way, we can bring production load to our staging environment without getting trapped by patterns in a fake data set. So since we can randomize and pick the number of events that we want to see every single time, the size and the type of the events produced are different with each test. So engineers build out a simple load profile like I described, and with just three things really. You've got the topic that you're reading from, the topic that you're injecting to, and then what you want to see. And then they can run in our staging environment as long as they've notified anybody who might be affected, and enough worker nodes are free. So this also ties back into our testing building blocks idea. We run one big load test on the entire system after all the system tests pass during our pre-deploy run, but engineers can also compose their own individual load tests for their own subsystems with any other kind of system testing that they would like. So now we had something approaching a fairly decent tool chest for our architecture. What other kinds of things could we take a different approach with and improve? So system measurements and requests from leadership and whatnot are great tools for informing what we do next as an ops team, but without soliciting feedback from people using our tools and fixing bugs based on the information we provide them, there's no way to know if our method is working for anyone else. So we started on this track of reinventing our tools and just trying to leverage all possible resources we had because it was taking us too long to test, in particular the new PowerTrack version. And we were so focused on keeping up that we weren't collaborating well with the rest of everybody, and we weren't providing as good of tests or helpful results as we possibly could have. If nobody is getting good information from the tests you're writing or from what you're doing if you're testing, Even if that's your job description, you shouldn't be writing those tests. We were catching some bugs, but we weren't working at pace with the rest of the org, really, and we weren't preventing all the faults that we could have. So it's important to take time to consider your solution every so often, change up your approach if you need to, and iterate to stamp out any edge cases you might not have considered. It's also important to consider what kind of organizational culture that we want to work in. Do we want to move as fast as possible, or do we want to provide stability for our customers, or do we want to balance these needs? We've shifted to a less high-touch model of testing and deploy for QE as we've evolved as a team, and the apps we test have grown and changed, but we still have to balance the needs and desires of engineers with the contractual obligations we have to people who pay for us to build things. Giving engineers the ability to write their own system tests and run load tests when they want to, give an advance notice, has started to allow us to put less effort into every system test written. But the agreement we have contractually with some of our customers, you will get this many tweets at this time if they exist, should still be not ignored. Like, we still have to deliver a certain level of quality and pay attention to detail. But maintaining a quality product shouldn't be an excuse for not improving human process as the system and the organization grow and change. We do want to make sure that any new approach we try will actually meet the needs of our customers, but we also want to make sure we're creating precedent for a place where people get to work on new things and see them running faster in production, and where people can have an on-call experience where they're not getting paged repeatedly every night at 3 a.m. because no one likes that. If you do, talk to me, please. Especially with testing, it's important to experiment and to consider what could work best for your own org, your team of engineers, and how they think about testing and interact with each other, as well as your org's current stage of growth. Not every type or style of testing or of deploy works for every situation. We've had a quality engineering team since we were GNIP because it's continued to work for who we are and the way our systems are. But this is just one way of doing stuff. There are many possible ways that you could catch distributed interaction problems, and I haven't thought of them all, but they're out there, I'm sure. We just want to make sure that we're doing our best to give people a reason to continue to work with us, both as engineers and as customers. So for now, the quality engineering team is providing and maintaining system test and deploy tools and process, but that may not always be the case if the org changes again. System testing in data products at Twitter is an evolving process, and I can't wait to see where it goes next.